with me here is Linda, and she will tell us a bit about her PhD about machine vision in everyday life, which is about object recognition, facial recognition, and emotional detection. And it is really interesting how she and her colleagues are working with this whole topic and putting it also in some art projects. And I'm really happy to have Linda here. Her talk or part of her presentation will be pre-recorded. So don't be irritated by that. For technical reasons, we said, okay, we'll just do it with a recording. And now I say, hello, Linda.
Hi. Yes, so I'm very happy to be able to present for you today. It's about my PhD research, as Claudia said, and also about the art that I do with my partner, Andres Zingele, who was also presenting actually yesterday, some of our research that we did in Korea. So I'm tying up all these things in the presentation.
Cool. Would you like to just hop right in?
Yes, let's start the video and then we can talk more.
Okay, so screen on.
Hi, my name is Linda Kronman. I am an artist and a researcher. As an artist, I work together with Andres Zingele under our collective name Kairos. Besides being an artist, I am currently a PhD candidate in digital cultures at the University of Bergen in Norway. Here I work in a project called Machine Vision in Everyday Life. The project and our team is led by Professor Jill Walker-Retsburg. My focus in the project is how machine vision is represented in digital art. In my research, I analyze surveillance art and related machine vision technologies using feminist and post-human theory. I will take this opportunity to shortly present my research in the machine vision project and how it links with research into smart cities I conducted with Andres Zingele when we were based in South Korea, and with our latest artwork, Suspicious Behavior. To give you a little bit of context, I will start with my PhD project. In this digital humanities project, we have been building a relational database to structurally analyze how machine vision is presented in art, games, and narratives. In an iterative process, we have built a classification system which helps us to analyze very different types of work, ranging from generative art, interactive artworks, and games, to films, novels, and short stories. In our analysis, we consider how the machine vision is portrayed in the work. Among other things, we tag what sentiments or dominant attitudes towards machine vision are shown in the work. For example, is machine vision represented as something positive, like helpful or empowering, or rather negative, like intrusive or oppressive? As we quantify our subjective readings of cultural works, we hope to be able to draw some conclusions of how machine vision is represented to us through culture. From each work in the database, we create one or more machine vision situations. Here, our intention is to analyze how agency is distributed between humans, other species, machine vision technologies, and other entities. Basically, we are trying to describe what both human and non-human actors do in complex machine vision assemblages. By the end of this year, we will have the data collection part done, and we already started to test different datasets, exporting them from the database and mainly visualizing them in Gephi. Both creating a classification system and classifying about 120 artworks has made it clear for me that the chosen categories and how we classify these works strongly shape the outcome of our visualizations. However, classification is necessary to make use of any data, but a big part of our project has involved being explicit and documenting the decisions we made throughout the project.
Further, building a classification system has drawn my attention to artists whose works scrutinize how collecting, categorizing, labeling, classifying, and cleaning data play a fundamental role in shaping how machines see. So, in my individual part of the PhD project, I have focused on analyzing on how art furthers an understanding of how values and worldviews get embedded into what is often popularly called artificially intelligent machine vision. And when I talk about artificial intelligence in machine vision context, then my focus is on supervised or semi-supervised machine learning approaches. So this basically means that neural networks are trained to see objects with the help of large collections of labeled images called training sets. From our list of machine vision technologies, this includes facial recognition, emotion, motion, action, and object detection technologies, often as part of surveillance assemblages, including surveillance cameras, camera phones, drones, satellite images, biometrics, and so forth. To be a bit more precise, I will give a couple of examples of how artworks can aid an understanding of how training data shapes the ways machines are designed to see. Max Dowie's artwork Hipster Bar is a good example, demonstrating various aspects of discrimination that is embedded into machine vision. Discrimination both in the sense of making a distinction between people either in favor or against them, as in oppressive algorithms, and in the sense of making a distinction between things, as in automated classification. So for the Hipster Bar artwork, Dowie trained a facial recognition software with 5,000 images tagged as hipster. The images he scraped from Instagram. Thereafter, he cleaned the data set by removing, for example, images of avocados and dogs. After being trained, this machine is able to link certain facial features or accessories with the characteristics of a hipster. Thereafter, the machine was automated to make decisions based on a given intuition by the rule of if more than 90% hipster, then allow access to bar. This means that the machine is delegated the power to both create meaning and enforce judgment. This is a relatively simple example of how the developer of a machine vision system becomes the lawgiver, assigning absolute authority to the machine, in this case enabling access to a service. Hipster Bar exposes in a playful, however explicit way, how bias gets hard-coded into machine vision. It exemplifies that training sets play a fundamental role in what machines learn to see. It also demonstrates that technologies that classify humans always will benefit some users more than others. Here the hipster gets a drink at the bar. Those discriminated based on their appearance are denied access. In real life, those who experience discrimination by AI systems most often belong to systematically marginalized populations. Intelligent machine vision systems failed Robert Julian Borak Williams when he was arrested because of a false facial recognition match. Joshua Bada's passport image was flagged because it didn't meet the requirements of an official passport. The system claimed his mouth to be opened. Bada noted that his mouth is closed, he just has big lips. And like Shadi Petosky, many transgender individuals experience harassment by security officials on airports. This because their bodies are flagged for anomalies by body scanners that only recognize the binary female-male choice on the machine vision interface. These examples depict that AI is not equally convenient to everyone. They cause stress situations, microaggressions, and considerable harm to many people. An increasing body of research reveals that the ways machine vision technologies are designed and employed reproduce existing injustice. Intersections of race, gender, and other identities and attributes shapes people's experience with AI. Discrimination is most often experienced by those who already belong to systematically marginalized populations. American Ghanaian artist and computer scientist Joy Bulamwini's work is dedicated to demonstrate how AI is intersectionally biased. In Coded Gaze, she demonstrates how most facial recognition applications benefit some users over others. She describes how she is invisible to the machine gaze until she wears a white mask. In the video, Bulamwini asks the question, what the training data actually represents and what is left out. Later in the Coded Gaze video, Bulamwini makes it explicit that facial training sets lack in diversity. Like the UTK face training set exemplifies here, they disproportionately represent white people. Because of this, the technology fails to detect faces with darker skin type. In AI, Ain't I a Woman? Bulamwini demonstrates how another type of facial recognition tool fails, as she shows how gender classification products, despite high accuracy scores, misinterpret iconic Black woman as male. In her thesis, Gender Shades, Bulamwini developed an intersectional benchmark. A benchmark in machine learning context is used to measure the accuracy of a model. In this case, the benchmark was designed to test how well popular gender classification products recognizes face by gender, skin type, and the intersection of gender and skin type. With the new Gender Shades benchmark, the results showed notable differences in the error rates between different groups. When training data causes unwanted bias, the typical tech fix is more data. But attempts to diversify datasets can also lead to reproduction of racist classification schemas. One example of this is IBM's Diversity in Faces, which was a response to critics of bias in facial datasets. So IBM's attempt to diversify a dataset was to add more data points, including skull shapes. IBM's choice to use skull shapes is rather strange, as it neglects histories of using craniometry that was used to claim superiority of white people over Black people. More data does not lead to neutral nor objective outcomes. Classification taxonomies are scrutinized by artists Kate Crawford and Trevor Paglan in an exhibition called Training Humans. In the exhibition, Crawford and Paglan exhibit historical and contemporary machine learning training sets. With their media archaeological approach to excavate hundreds of datasets used in AI, the artists wish to unfold, I quote, what normative patterns of life were assumed, supported, and reproduced, end of quote, to inform how AI works and fails. Among other training sets in the exhibition, we find the selfie dataset and the UTK face dataset. The selfie dataset contains over 40,000 images annotated with 36 different attributes divided into several categories, including race and gender. UTK face dataset consists of over 20,000 face images with annotations of age, gender, and ethnicity. The dataset exposes how images in training datasets are systematically labeled according to normative values. In both datasets, images are labeled according to binary female-male classification, which assumes gender to be fixed and determined by biological sex, and excluding any other possible gender embodiment. Images are also classified in line with racial schemas, reproducing racial taxonomies. Further, face attribute classification tools can quickly turn into applied physiognomy. Machine learning models have been trained to recognize gay and criminal faces, assuming that inner characteristics of a person can be read from the appearance of one's face. Facial recognition technologies are currently facing a lot of critique and pushback as researchers, artists, and activists advocate for regulations and bans. Less attention has been given to machine vision that is intended to detect and even predict actions, in other words, behavior. For the artwork Lacework, Everest Pimkin was systematically looking at the 3-second videos in MIT's Moments in Time training dataset. In this dataset, actions are categorized into 339 verbs, starting alphabetically with aiming, applauding, arresting, ascending, asking, and so on. In a text that accompanies the artwork, Pimkin describes watching all of the 1 million video clips in the training set, most likely being the only one who has seen them all. Pimkin doubts that the researchers assembling the dataset have seen most of the videos, because it's time-consuming and hard. However, all of the videos have been seen by some humans, as the videos of Moments in Time were automatically uploaded to Amazon's Mechanical Turk for annotation. In this context of critically analyzing training sets, our work Suspicious Behavior examines aspects of collecting, categorizing, and classifying action detection training sets, with the intention of building machine vision to detect suspicious behavior. In this interactive narrative, a fictitious scenario is built up, in which the user is given the role of an image annotator, performing human intelligence tasks or hits for a crowd-working platform. The task is to label videos for training smart cameras to detect suspicious behavior. Our interest to investigate automated surveillance initiates from the smart city research we conducted during 2018 and 2019 in South Korea. At this time, we visited a number of smart city showrooms, like the control room in Songdo or the one in Busan Smart Eco Delta City. These showrooms promote citywide intelligent surveillance to be the solution for safety and crisis management. They are one solution in a box models imagined to serve a common good and to be beneficial for the universal smart citizen. Surveillance is a big part of the smart city industries. This was also evident when we visited big industry fairs like the Smart City World Expo Congress. In this context, training AI to detect suspicious behavior is presented as neutral, actually promoted as a way of bypassing racial profiling. Nevertheless, as I have tried to argue throughout this presentation, the ways training data is collected, categorized, and classified will shape the bias of machine vision. So we were curious of various phases in assembling an action detection training set and what kind of assumptions, patterns, and biases they embed. What is defined as suspicious and contrary normal behavior? How is it categorized and classified? Who defines it? We looked at a number of training and benchmark datasets that are openly available, described as action detection used for surveillance purpose. Even if the datasets are quite small in terms of big data, we were overwhelmed with the amount of video footage. For example, we were not even able to download all of the material without exceeding the memory capacity available for us. So in contrast to Everest Pimkin's strategy ending up watching everything, we approached the dataset from the perspective of a data annotator, who is given the task to annotate fragments of a training set. Through a fictional annotation tutorial, we could think about various aspects that goes into building and designing a training dataset for machine learning. The tutorial starts by proving that you are human, referencing to a form of image annotation we perform without payment. Thereafter, the user is recruited to become a click worker with a mashup of YouTube videos describing data annotation.
Nowadays, everyone seems to be building artificial intelligence. No one talks about one of the most important aspects of the work, data annotation. The people who are undertaking this time-consuming, boring task without the flair that usually encircles AI.
AI offers a path to a job in a different kind of factory.
How to make money tagging photos online.
Some easy and PayPal money just by labeling things online.
Data labeling is the process of attaching meaning to different types of digital data like audio files, text, images, videos, and more.
How does it work? It's pretty simple. We give you tasks, you do the task, and you get paid.
Mommy just earned $1.
And you're going to be basically helping artificial intelligence, okay, helping out computers, robots to do like tasks that only humans can usually do.
The superheroes of AI development, data annotators.
After an introduction to the job, the trainee is asked to start annotating videos. These videos are from open training and benchmark datasets for action detection. The time to decide whether a scene is suspicious or not is limited to 10 seconds. And the trainee is challenged to rely on intuition rather than reflection. What is considered suspicious in one cultural context might be normal in another. And also developers of these technologies admit that it's challenging to match specific action to suspicious behavior. Nevertheless, the surveillance industry is developing smart cameras to detect abnormal behavior. Gradually, the trainee is provided with guidelines that what to look for. Lonely objects, waiting at the corner, repeatedly looking back or lingering are just some of the actions defined as suspicious by various authorities. How suspicious behavior is to be detected is strongly linked to prevention of terror attacks. However, the tutorial reveals how complex human behavior is reduced into banal categories of anomalous or normal behavior.
Further along the tutorial, it becomes clear that the underpaid click worker needs to train both on speed and accuracy. For this, the trainee can turn to the advanced training modules. Here, the trainee gets to explore specific training sets and discovers that action datasets are either weird scenarios in which amateur actors perform overemphasized movements, or real-life scenarios collected without consent, scraped from videos on YouTube and LiveLeak. The assembling of action datasets face similar ethical challenges as facial recognition datasets when individuals are included into openly available datasets, whether they want it or not. We were working with this tutorial during the lockdown in the first wave of the pandemic. We also realized that the definition of suspicious shifted. Suddenly, bigger crowds were suspicious, and machine vision was developed to detect distance between people. A number of applications were demoing how to detect if a person is wearing a mask or not, and the need to identify faces behind masks was another field of inquiry. However, from a privacy aspect, these technologies should be and have been scrutinized. When such surveillance technology is rapidly implemented as a response to a crisis, the public might be more open to accept it. However, it opens doors for using it in unintended context, and we should stay alert to who is ultimately benefiting, who might be harmed when these technologies are put into place. To wrap up, suspicious behavior is an outcome of an inquiry into data practices of assembling action detection datasets. It is inspired by a number of art-led research methods of analyzing training data for machine vision. It raises questions how classification taxonomies shape the way machines see. In this short time, I hope I made you curious enough to try it out. The work can be experienced online. Thank you for listening, and hopefully this presentation raised some questions that I will be available to answer now.
What a great hint from our technical team. Thank you very much. I muted myself during the presentation. Very good. So we're back here in our virtual studio. Yes, it's a really, really interesting thing to work on. Linda, how did you come by that topic?
Yeah, so basically it was much about working with topics of surveillance during our stay in Korea. We did another artwork called Panopticities, where we looked at streams of unprotected surveillance cams, and then also like kind of these reports and that you could read in the news that, for example, Amazon Ring is using. There was a leak that Amazon Ring is using their footage to annotate video streams. But then I've been interested in this like how we classify these things. How do we classify things that are then kind of shaping the ways that these technologies are seeing the world? So all those things came together in this piece. So
we do actually have a question from the audience. In your experience, how did you perceive the difference in acceptance of machine vision techniques between people in South Korea and Europe?
So, of course, in general, privacy is a very different concept, or it's a non-existing concept amongst the Koreans. Because their technology is embraced in very different way. This has cultural backgrounds. Also, for example, we know that in Japanese cultures and so on, the machine is seen to have a spirit and so on. So, for example, how East Asian cultures are with machines it's quite different than we have in Central Europe or in Europe, North Europe. So these technologies are way more embraced than they are used there. So, for example, in Korea, also already facial recognition is and emotion detection is used, for example, in job interviews. And there are, of course, critical voices also in Korea, not many, because this is also very much like the tech, like from South Korea being kind of the poorer Korea when they were divided, and then after the war that they raised through technology. This has become a very national thing, but there are critical voices. We've been working, for example, with Unmake Lab, who are kind of critically looking at technologies in South Korea.
Okay. Thank you. If there are any more questions with you in the audience, you can still hand them in via Twitter and Mastodon with the hashtag PW20 and PW20 online, as well as our question form. You can find that on the streaming site with the button Ask a Question, or you can go to privacyweek.at/ask. What struck me during your presentation was the part that female people with darker skin were the least well detected in AI or machine vision. Is it only because of the training data, or do you have a further explanation for that?
Like basically, probably it's mostly like the lack of diversity in training data in this case. Of course, biased systems, like the bias comes from many different things. It's also like the choice of algorithm, choice of model, and how you build it, and adjustments that you make, and so on. I'm basically like focusing as a visual artist and visual person. I'm focusing on the data sets because I can approach them better as like artifacts. But of course, like there's also like kind of this discussion in the field of discriminating AI and like then on the other side, like what should be fair or ethical AI. There's also like a conversation of that there are not the right people in the development teams to ask those questions, to see that kind of. So there's also like kind of a lack of diversity in the AI field, which is like, of course, like historically also like a lack of diversity in designing technologies. And what is promoted a lot is, of course, like getting more people involved in the design processes, in the development processes, like participatory approaches in designing, and actually including the communities. I mean, these data sets, sometimes it doesn't matter if, I mean, of course, it's problematic if it's not able to detect like certain faces and so on. But it's also like very much like how these technologies are implemented, if it matters, if the data set is biased, and in which way it is biased. It will always be biased into some direction. And how do you then correct bias? And there we come to like judgments that the design team needs to make and be explicit about. Why did we decide it like this? But it's basically, it's not neutral and it's not objective, but there needs to be a conversations of how it's biased and if it's justified to be biased in certain ways.
I think one dimension of the problem is that all the technology is not located in only one area, but has the potential to reach the whole world. So people from every country, every region, every continent. Yeah. So it meets all of us. And I think we actually really need a global conversation on that problem. Do you see any possibility to get one global conversation to that?
I mean, of course, currently, like, nation states are put in a way against each other in this race in AI, and it's like this war in AI, which is not very productive at all. I think it's also like not just to have the conversations between maybe like geographical points, but also like finding the way of having a conversation between like artists and academics who are maybe looking more like kind of on these things, like on a socio-technical with a socio-technical approach, and conversations with developers where there's not like kind of this feeling of saying that, you know, you did this wrong, or this like, or that you don't understand how these technologies work, but to have a conversation where we see like what are the problems. And there are like a lot of initiatives now in the field of like AI, like ethical AI, responsible AI. They go under different names with a little bit of different approaches.
And hopefully a lot of difference in all the people that AI will more or less meet sooner or later.
Yeah, a good like just published book on thinking about like, or how to rethink design of technologies and rethink design of AI as well is Design Justice. It's also a movement. The book is by Sasha Constanza Shaw, and they're like a lot of this. It's a conversation starter, I would say.
Good, and I think we need a lot more conversation here. So I actually learned something new today, or it was something I actually never thought about before. And this is, thank you very much for making that clear. But all the transgender people having big problems. You had the example at airports where there are pictures of the body scans and so on that brings those people into troubles, being asked about something and so on. Thank you for making that point, because I never thought about that, and this could probably be the same for lots of people who hopefully just saw this talk. But I think in that area, in the whole transgender area, we have lots to think about AI and facial recognition, emotional detection, and so on. Do you have an extra pinpoint for that area in your work?
I mean, it's like basically when you read this literature of when technology, kind of this type of technologies fail, it's very much about like that it fails for marginalized groups, and it doesn't fail for us because we are basically white people and privileged people, and we are also the ones basically currently the ones who are more or less designing the technologies. So they work for us, and then it's very easy to not see it working for a big populations, big minorities who it's not working for, who it's actually working often against. And this is something to keep in mind, and this is something that like can also be brought through artworks and through like kind of these kind of investigations to the forefront.
Is there anything you would like to know all the people outside, or where we can find more of your work or other reading hints or anything that you would like to hand out to our audience?
Yeah, I mean, there's Of course, there's the machine vision project. We have a website where you can read also like the suspicious behavior. Actually, we have like when you explore one of the data sets, we have included references there, and there's also like readings and like kind of this material there, so you can kind of through the artwork you can also dig deeper into where our ideas are coming from, so from readings from other scholars and artists and so on. And and also like there are, for example, AI Now Institute in New York is one good place to start thinking about like how systems discriminate. They do reports that have a lot of references, and Rua Benjamin's Technology After Race, or there's a lot of writing on this currently, so which is
good.
Yes.
Thank you very, very much. It was a pleasure having you here. I know you have an important appointment in a very short time. All the best wishes for that. And thanks again, Linda. The big applause we all think now.
Yeah, and thank you very much for putting up such a great week with such a great program.
Thank you. I will hand that over to the whole team.
Yes. Okay, thank you.